Today's video is brought to you by Miss Renee's Educational Services from EFSY.org. And we'll be discussing the effect of collision frequency on reaction rates. So hi, thank you for subscribing to our channel or coming to view our videos here on the channel. For everyone who has watched me over the past 2 decades teach chemistry, they're familiar with my lemon limeade chemistry juice. We sold many of the juices after we completed our experiments, and the juices helped an affiliate put a mobile classroom on the road. So we'd like to continue with our chemistry juice and some of the examples of other chemical reactions. Stay tuned. So let's start with the classic experiment using an Alka-Seltzer tablet. When we drop a whole tablet into room temperature water, it fizzes as it dissolves and reacts with the water. But what happens if we crush the tablet first? Let's look at the whole tablet versus the crushed tablet. The crushed tablet reacts much faster. Let's look at this video and then we'll come back.
Hi, my name is Twang and I am a grade 11 student from St. Joseph's College School. Today I'll be showing you a science experiment that will be about discovering a link between the size of a particle and the rate of its reaction using Alka-Seltzer tablets. Since these tablets are medicine, make sure to ask a trusted adult, a parent, a guardian before you can use them. For this experiment, you will need 2 glasses of water that are filled 8 ounces or 240 milliliters, an empty glass, a separate bowl of water that is 8 ounces or 240 milliliters filled, a stopwatch, 3 Alka-Seltzer tablets, a piece of paper, and a marker. Before we do the experiment, there are some preparations we need to do. Take your piece of paper and copy the chart you see on the screen. If you need more time, feel free to pause the video. Now open the Alka-Seltzer packages and get 3 tablets. Keep one the way it is, and take the second tablet and break it into 8 pieces. Finally, take the third tablet and grind it into a powder using a mortar and pestle or by crushing it in a bag. Part 1 of the experiment, using 1 whole Alka-Seltzer tablet. Have your stopwatch ready and place 1 glass of water in front of you. Then take 1 Alka-Seltzer tablet and drop it into the water. If this gets too hard for you, you could always ask for help. Make sure to start your timer the moment you place a tablet in the water. As soon as you think there are no more bubbles forming, stop your timer and record the time it took for the tablet to dissolve. And don't forget, make sure to not drink any water from the experiment. Part 2. Breaking an Alka-Seltzer tablet into 8 pieces. Repeat the same steps in part 1 and drop the 8 pieces of Alka-Seltzer into the glass. Start your stopwatch, and once you don't see any more bubbles forming, stop your stopwatch. Record your results in your table. Part 3. Grinding an Alka-Seltzer tablet into powder. In this step, take an empty glass and place your Alka-Seltzer powder inside. Once you are done, start your stopwatch as soon as you pour water inside your glass. Make sure to pay extra attention to the time it takes for the powder to dissolve. And stop your stopwatch as soon as you see no more bubbles forming and record your results in your table. After completing the experiment, what thoughts went through your mind when you were looking at your results? For example, were you surprised how the powder formed in the tablet dissolved the quickest? Well, before we go any further, we need to know how an Alka-Seltzer tablet actually works. When an Alka-Seltzer tablet is placed in water, it starts to dissolve and form bubbles. This is called a chemical reaction. A chemical reaction is a process by which one or more substances are rearranged to form different substances. In order for a chemical reaction to occur, particles must collide with enough energy. Some examples of signals that a chemical reaction took place are gases forming or changing color. In every chemical reaction, there are reactants and products. The reactants are the starting chemicals in the reaction, and the products are the chemicals that formed after the reaction. In our experiment, the reactants sodium bicarbonate and citric acid are combined to produce water and carbon dioxide. Let's go back to the topic of the Alka-Seltzer tablet's rate of reaction. The reason why the powdered form of the tablet was able to dissolve faster was due to the increase in surface area. Surface area is the sum of all the faces on a three-dimensional shape. By decreasing the size of a reactant, the surface area will increase, raising the chances of particles colliding with each other, making the rate of reaction faster. Think of it this way. Here's a cube where each side length is 2 centimeters. To find out the total surface area of this cube, you must figure out the area of one face and multiply it by 6 because each side on this cube is equal. The area of one face on the cube is 4 centimeters square. That means the total surface area of this cube is 24 centimeters square. You can do this calculation by multiplying the length and width of one side of the cube and multiply it by 6. Now let's cut that same cube into 8 smaller cubes. Now each side length of the small cube is 1 centimeter, which means the area of a face on the small cube is 1 centimeter square. The total surface area would then be 6 centimeters square. Since there are 8 small cubes, you can multiply 6 centimeters square by 8. This comes to an answer of 48 centimeters square. As you can see, the surface area of the cube cut into 8 smaller cubes is more than the surface area of the cube in the original size. The 8 smaller cubes allow more access for reactions to take place. Let's take a look at the table we filled along the experiment. Don't worry if your results don't match with my results in the table. As long as you are in a close range, you should be alright. As you can see, the powder form of the Alka-Seltzer tablet had the fastest rate of reaction. This is because we broke the tablet into smaller particles, increasing the surface area. In conclusion, the smaller the particle size is, the faster its rate of reaction will be. And now you finally know the link between the size of a particle and the rate of its reaction. If you would like to see more content, subscribe to our YouTube channel and follow us on our Facebook, Twitter, Instagram, and TikTok at Pueblo Science. If you upload your science experiments online, you can tag us as well. See you next time!
So that was a cool experiment with the Alka-Seltzer. Now let's look at the effect of collision frequency on reaction rate, fast versus slow reactions. We're going to look at sodium chloride and silver nitrate. Let's compare two different reactions. First, when we mix sodium chloride and silver nitrate, a white precipitate forms almost instantly. This is an example of a fast reaction. But what about the reaction of ethane with oxygen? This is combustion. And unlike our first example, it requires an ignition source and is much slower to begin. This shows how different reactants have different reactive speeds. Third scene, we'll talk about oxidation reaction, burning magnesium. Now let's look at oxidation. When we burn magnesium, we see our intense white flame forming magnesium oxide. This reaction follows our equation. You can see the on-text screen right here in the slide. Oxidation reactions are common in chemistry, and understanding them help us see how metals react with oxygen over time. Now, there are 4 ways to speed up a reaction. Now let's see how we can make a reaction happen faster. Hot water dissolves tablets faster. When we increase the concentration, more reactants cause a faster reaction. 3, if we increase the surface area, the crushed tablet reacts faster than a whole. 4, we use a catalyst, yeast and hydrogen peroxide speeds up oxygen release. And each of these factors help increase the number of effective collisions between molecules, making reactions go faster. So now in our final clip, we'll get to look at the lemon limeade chemistry juice. It's going to be a visual of lemon limes sugar or baking soda on the table. And now it's time for our favorite part, the chemistry. We'll use the fresh lemon and lime juice, baking soda, and water to see a fun acid-base reaction in action. We're going to show the juice squeezed into a glass, all of the ingredients added, and then the citric acid in the lemon and lime juice reacts with the water and the sugar. And if you're using baking soda, it will release carbon dioxide bubbles. This reaction is similar to how carbonated drinks are made. And the best part, it's completely drinkable without the baking soda. So let's stir in a little sugar and enjoy this refreshing chemistry experiment.
All right, some lemon juice, some sugar, and water. Perfecto. Now let's mix it all up. Mix, mix, mix. Keep mixing. Oh, hi guys. Welcome to the Wonder Lab. Today is such a hot day and I'm trying to make some lemonade. But you see, it doesn't seem like the sugar is dissolving. I don't think it's supposed to be this way. What am I doing wrong? It's still crunchy. Oh, I think I know what I'm doing wrong. Remember my chemistry class? The rate at which a solute dissolves depends upon three things. First one is temperature of solvent, which in our case is water. Second is surface area of solute, that's whatever we're dissolving in a solvent. And third is stirring or agitation. Just so you guys have a better idea about how temperature affects the speed at which things dissolve in water, let me show you an experiment. So into this glass here, I'm going to pour ice water. Into this one, room temperature water. And into this one, I'm going to pour hot, almost boiling water. And I'm going to put a drop of dye into each glass. As you can see right away, higher temperature increases the speed at which the particles move. More rapid motion means that the water particles collide with the particles of dye more often and with greater force. Hence, the dye dissolves faster in a glass with hot water. Stirring or agitation also increases the rate of dissolving because you make the particles of both water and dye move quicker, allowing them to collide more frequently. In the next demo, we will see the effect of surface area on the rate of dissolving. I'm going to put a teaspoon of granulated sugar into one glass of room temperature water and a sugar cube into another glass. I will agitate them at the same time. In which glass do you think the sugar will dissolve quicker? Well, like we saw in the previous example, creating more contact and collisions between the solvent and the outer surface of the solute increases the rate at which solute dissolves. In this case, our solute is sugar. So that means the more exposed surface area sugar particles have to the water, the more chances of contact they have. You can see even when stirring, the cubed sugar still has some undissolved particles, while the granulated sugar has already disappeared and formed a solution with water. Well, these chunks of sugar do seem to be big, and I am using cold water. Seems like I will need to go the long route, a little bit longer route, in order to make this right. So what we're gonna do is crash. No, just kidding. We're just gonna use normal sugar. So what we're going to do instead, guys, is we're going to make a sugar syrup. We're going to dissolve 1-to-1 ratio of water and sugar in a saucepan on a low heat. Like I said, we're gonna dissolve half a cup of sugar in half a cup of water. And we're gonna stir this until sugar dissolves fully and the mixture looks uniform. All right, guys, let's try this again. This time, I'm going to make this lemonade just right. So now that we have our sugar syrup, I'm going to pour it in. So I'm gonna use a lemon squeezer, which catches all the seeds. Let's add some ice to this. And probably add a little bit more water because it might be a little bit too sweet. Let me give this a try now. It's perfect. It's not too sweet, it's not too watery, it's not too sour. This is perfect. So now you know how to make your own lemonade, and you also know the effect that temperature and the size of particles have on the rate at which they dissolve. And we have used this knowledge to make delicious, refreshing, and most importantly, evenly dissolved lemonade. It's summertime, it's getting hot, so I encourage you to go into your kitchen and try to make your own lemonade. Thanks for watching, and bye for now.
So, I hope you enjoyed today's experiments and learned something new about chemical reactions. Don't forget to like, subscribe, and leave a comment if you tried any of these at home. And thanks for watching, and I'll see you during the next tutoring session.